We set up a simple class with a constructor in the previous video, and this time around let's take a look at constructors in a little bit more detail. So constructors are always set up in Java, C++, C#, or Objective-C to initialize data members inside an object. So the main reason for having constructors is initialization of objects. We initialize typically all of the data members or member variables. I'll use those terms interchangeably. Sometimes you only have to initialize some of the member variables. Once we start using inheritance, we will rely on the constructor of the superclass to initialize data members that belong to the superclass. We might also have other actions, like maybe initializing some other member. Let's say that's an object that belongs to the current object, but maybe it's not completely inside it. And also other actions like setting up the state of a file, for example, opening a file, things like that. One thing you don't want to do, as much as possible, try to avoid putting couts or print lines in Java inside a constructor. Now we will do this for testing purposes. Yeah, we will put in some couts, but for the most part, I guess a rule of thumb would be if you don't need a cout, don't put it in, and just avoid it as much as possible. Don't put couts into constructors. Okay, so if you're used to constructors in Java, you know that constructors are methods or member functions, as they're called in C++, but they are a special kind. So constructors are special. They're automatically called when the object is declared. They can be overloaded just like any other member functions. They don't have a return type. So in some ways they're special, in some ways they're just like any other function or method. Very useful tool. It's a key principle of object-oriented programming. If you have inheritance, especially, the whole idea of inheritance is to reuse code, and so typically when you have a constructor, you usually do not redo or rewrite the same code that you had in the superclass. You call the constructor of the superclass instead. So a key principle of reuse and object-oriented programming. Okay, so constructors are defined just like any other member function, except, so there are some key differences. Just like in Java, they must have the same name as the class. Cannot return a value, not even void. They are just like any other member functions in that they can be overloaded. But in C++, you will see that there is going to be a very special constructor later on that we look at. It's called a copy constructor, which we can set up in Java, but it doesn't have the same sort of language support that C++ copy constructors do. So for now, we'll just not worry about it, and we'll get to it pretty soon. So here's a simple example of a class with a constructor. The class is day of year, and you have a constructor in the public section. Now, for almost everything, our constructors should be in the public section. There will be special cases, actually, where you would want the constructor in the private section. Believe it or not, you might wonder, why would you want to do that? Because you'll never be able to use it. It turns out, yeah, that's actually something you might want to do sometimes. And there's one special situation where we would need the constructor in the private section, but let's just say that for now, all of our constructors are going to go right into the public section all the time. Okay, so in this case, we are not showing the method bodies. They are in the method definition. So the constructors, just like other methods or other functions, the method body can go into a separate .cpp file. And this part, which is just the definition, sorry, the declaration, I would say this is the declaration. Shouldn't say definition. This is the class declaration. It can go into the .h file. Okay, so notice the name of the constructor is the same as the Name of the class does not have a return type, not even void. Constructors are in the public section. It's called when the objects are declared. If it were private, you could never declare objects, but just keep in mind there's a special situation where you would want the constructor to be in the private section. So this is true. If it's in the private section, you may not ever be able to declare objects, but there will be one situation where you would need it. Okay, so how do you call a constructor? Here there's one big difference between when you consider the case where you have parameters. So let's just take a quick look at that. So this was the class we set up, XYZ. We keep our names short, just so that to keep things simple, and we have a constructor with 2 parameters. And remember, just like in Java, you have a default constructor, and if you don't declare it, you sort of lose it. You cannot use it. So here is the xyz.cpp file that we set up last time, in our last video. And here's how we call the constructor. We pass in 2 parameters. So normally, if you have no parameters to call, this is what you would use. You would say xyz, which is a class name, and you'd say y. And here's the big difference is if you have no parameters, you do not put in the parentheses at all, because that won't work. It'll give you an error message. So you want to do this. Okay, so let's see if this will work. Save it, compile it, and we get an error just like we would in Java because there is no default constructor. So it says, I don't know if you can see it, but the error is no matching function call to XYZ. And okay, so let me just put that up again. So at the very end of it, it says no matching function for call to XYZ : XYZ and open close parentheses. So C++ did recognize that we are trying to call the default constructor with no parameters. But at the same time, you're not supposed to put parentheses here. C++ knows that if you try to do something like this, you are trying to call the default constructor. So the problem, even though it looks like it might be a problem here, it is not. So once again, I cannot emphasize this enough. For Java programmers, if you see something like this and you know that this is a class name, you might think, well, you're just saying that y is going to be a reference data type and object, and that's going to be an instance of this class. C++, even though it's not obvious, you are actually calling the constructor. And that's actually what the error message is all about. There is no constructor with no parameters. So a big difference between C++ and Java. And also between constructors with no parameters and constructors with 1 or more parameters. Okay, so what do we do to get this to work? All we have to do is go over here and set up a public default constructor. XYZ, open close parentheses, and we can put our constructor right here. And we can say x is equal to 0. That is, we can put our constructor function body right in here. Y is equal to 0. Okay. You do that, you save it, go back here, and compile this, and magically everything works. So notice, this tells us that we did not have to change this. We did not have to put parentheses here, as we would expect from this constructor, this call to the constructor, or this use of the constructor, I should say. We did not have to put parentheses. Now let's see what will happen if we did put parentheses. As soon as you do that, it looks okay, you save it, it looks okay, but compile it, and we should have gotten an error. All right. We didn't get an error, but we should have gotten an error. So you'll see in the notes that you should not do this. This is almost like you're saying there's going to be a function y that will return an object XYZ. So let's say we assume that now this Y object has been created. You can try to use it, Y dot something. Let's use one of these functions, which we don't have any function. So let's set one up and say int get x, and this all this will do is return the x data member. Okay, so a simple getter function, which should work. We go over here and we say y dot get x, and we will store that in int a is equal to. Okay, so let's see what happens. Now it's giving us an error. We haven't compiled it, and let's compile it. Okay, so if you look at this, it looks like we're declaring y to be an instance of the XYZ class. We're using no parameters for the constructor, but you'll see an error here. It says method getX could not be resolved, and it's kind of hard to see, but the second error message is request for member getX in Y, which is of non-class type XYZ. Okay, so what all this is saying is, even though it looked to you like you are just setting up an object Y, just like you did with X, this time you're calling the constructor or invoking the constructor with no parameters. What C++ thinks you're doing is you're setting up a function. You're saying that somewhere there is a function Y with no parameters that returns an XYZ object. And so it's saying, well, you can't do that. This is a function Y. So if you run into this error, you might spend 3 days trying to figure out why your program doesn't work. You just want to realize the problem is not here. The problem is actually here. You try to declare an object Y with a use of the constructor with no parameters, no arguments. What you need to do is not even have the parentheses. Now, save this, compile this, and everything works. Okay, so you do get a warning saying that A is not used, but that's okay. We can fix that by just using it. Cout A is A. Alright, save that, and this time around we should not even get a warning. Okay, so once again, the whole thing was we're looking at default constructor versus constructors with arguments, and what you saw is that if you have parentheses here, if you mistakenly put parentheses with nothing else and nothing inside parentheses, everything goes wrong. It looks like Y is just like X, but what you're really declaring is a function. Okay, so C++ has some odd things about it. Many odd things. Alright, so we did this kind of constructors. This is how we set up objects. We say class name, the name of the object, and in parentheses if you have one or more arguments to the constructors. So objects are created right there. It's created in the stack, unlike the Java objects where you say class name, object name equals new class name, and then in parentheses the arguments that go into the constructor. You can do that in C++. We just haven't hit that yet because that will be allocated in the heap. This is allocated memory for these objects are allocated in the stack. Okay, so the values in the parentheses are passed as arguments to the constructor. Okay, and the constructors will initialize these data members. And so this is just a repetition of what we did. You cannot call the constructor directly. So remember that, and we'll continue with that in the next video.